Well, this is Brady, and he's going to talk to you about how, I guess, Windows likes to have fun with itself, right?
All right, I guess you guys are a little too excited to watch Windows play with itself. So, yeah, we'll be covering some really interesting stuff today. First off, I guess a little bit about myself. I started out in the government space, doing a lot of cool stuff there. Like most of you, I'm passionate about security. Been doing it, ever since I was old enough to get in trouble for it. If any of you have heard of the Pono OS project, I started that project, and currently I'm a founder and principal security consultant at Silent Break Security. So throughout this, you'll see a lot of the techniques and tools that we've developed in conducting penetration tests. So, before we enter the danger zone for you Archer fans out there, I wanted to give you a little bit of background as to what motivated this talk. Okay, so back when I was in the government space, I remember talking to some friends in the private sector, and they were telling me about some of the difficulties they had and the differences between what a penetration test was and what an actual attack was, or what they were actually trying to defend against, right? So, fast forward, that was about 3 or 4 years ago. Fast forward, from that point a couple of years, and that ended up being one of the motivating factors to starting Silent Break Security, was to shorten that gap and to combine, what an actual attack is with what a penetration test should be modeled after. So that's typically how we, that's typically the methodology that we use when conducting penetration tests. So, there's still very few covert persistence tools on the market, right? A lot of us use Metasploit, and I'm a big fan of Metasploit. I'm definitely not going to badmouth it because I think it's an awesome project. But I think it is important to reduce the reliance that we have on Metasploit. And there's other great projects that do this as well, right? Such as Veil. Veil does it. Cobalt Strike is another great project that does it as well. So anything that we can do to customize and to model assessments and penetration tests after what organizations are actually defending against, I think is a good thing. So throughout my talk, you'll see some of the techniques and the tools that are being released will hopefully help you in doing that. So we have a lot to cover. We're going to first talk a little bit about DLL injection. A new technique for that, actually a few new techniques for persistence, stealthy persistence in a Windows environment. We're going to release Throwback, and I'll give you some demonstrations of that with lots of other demos along the way. So I'm really hoping the demo gods will be kind to me tonight. So first off, for DLL injection, For DLL injection, for those of us who have had to deal with the Windows API, that's often what it feels like, right? It's kind of a black box. It's definitely a black box. 3 out of the 4 APIs there are undocumented, right? So a lot of the options that we have and that we have to deal with, we have to reverse engineer and look at Microsoft DLLs and try to figure out, what Microsoft was thinking when they did things. The only documented one is create remote thread, but Microsoft has implemented quite a few restrictions around that with integrity level for processes and things like that. I've never been able to get into create thread EX to work very well. My favorite is probably RTL create user thread, which works really well most of the time. And then at the bottom you have NTQAPC thread, which can actually blue screen certain OSs. I think particularly Windows Server 2008. And then, for the really elite stuff, you can do code caving, which is also known as the Nebbit shuttle technique, but it's extremely difficult to do on 64-bit Windows. So, wouldn't it be nice to have another option, besides 1 that's documented and 3 that have very little support by Microsoft? So the new one that I found, it's called Add Monitor, and it's actually a port monitor. It's used to install a port monitor for a printer. There's some advantages and disadvantages of it, but it's still an awesome technique. So it takes 3 parameters and it injects into spool SV. So you don't have the flexibility of choosing what process to inject into like you do with some of the other APIs. But on the positive side, it doesn't require matching architecture. Typically when you want to inject a 64-bit DLL, you have to be coming from a 64-bit process. Otherwise, there's a little trickery involved. So it's super easy to use. In a minute, I'll show you the source code and we'll go through a demo. But it takes literally 3 parameters. The last one there is the most important one, which is a monitor info 2 structure. And again, in a second, you'll see what's contained within that. The biggest disadvantage in my mind is the DLL has to be on disk, and it requires administrator privileges. So with that, let's check out the DLL injection demo. And this one I recorded just because we have a lot of other cool stuff to cover. So. Okay. So let's see. I can't see very well from here. Hopefully, you guys can see better than me. But you can see that the command line argument that we're passing in is the name of the DLL that we want to inject, right? The part I just highlighted was the monitor info 2 structure, which again has 3 parameters. One is just a generic name. The second one is actually the architecture of the system. And then again, the third one is the DLL name that we're specifying through the command line argument. You need the SC load driver privilege, which is, you can easily obtain with admin privileges. And then the last one is, you just call the function or the add monitor API with the necessary parameters. So I guess to prove that it's being injected in a spool SV, I loaded up Process Explorer there in the background, highlighting spool SV. So when we actually carry out the demo, you'll see that the DLL gets loaded into spool SV. In this case, the DLL is just a test DLL that I wrote. It'll do a hash dump on the local system. So, and then it'll dump it to debug view. So, it's a pretty basic demo, but as soon as we run it, I'm going to drop back into Process Explorer here so you can see that the DLL, you should see a green line appear showing that the DLL got loaded under spool SV. There's the green line. So the DLL is running within spool SV right now. It just got loaded. And now if we check out the debug view, that DLL should have dumped out done a local hash dump. And you can see that it ran from the spool SV process. So, obviously in this case I chose the DLL to do a hash dump. In your case, it can basically do whatever you want it to do, whatever you design the DLL to do. So that's the DLL injection technique. Let's see from there. Okay, so from there, I want to talk a little bit about persistence. So first of all, there's lots of persistence mechanisms in Windows, but which one do you guys typically use? Who uses a service, first of all? Come on, you liars, raise your hand. You all know that you use a service, right? If you have system privs, that's what you typically use, right, as a service. Right? That's like what the APT1 report by Mandian is now what it said, like 75% of all attacks create or install a service, according to my good friend, Bryce. So we do have other options, right? There's run keys, there's SCH tasks, but wouldn't it be nice if we had another option, especially something as simple as dropping a DLL to disk and creating a registry key and then having that be loaded on boot into a system level process. DLL is super stealthy and we can design the DLL to do whatever we want. So, like I said, there's lots of techniques. The technique that I use to find this, I'm going to talk about 3. I don't think the techniques that I used to find these are new. Definitely not. I just used Process Monitor. And in this case, you can see that on the left, I had Process monitor specifically VMware tools. And then, I just went through all the different processes, had it monitor that process specifically for DLLs that were loaded, and then first of all, stopped and then restarted services one by one to see which DLLs got loaded. You can see there in the middle, it says name not found. Well, it tried loading the ntds api.dll from the WBEM directory before it tried loading it from system32. So there's a DLL hijacking vulnerability there, right? So if we drop a DLL into the WBEM folder named ntds api, ours will be loaded as that service on boot. So it's kind of a cool technique, and that actually is one of the techniques that I'm disclosing right now. It's kind of a funny story that goes along with this, though. The second technique that I had listed, actually, I found those probably like 3 years ago, back when it was ESXi, 4.0, 4.1, and I just kind of sat on them, didn't do much with them, and then finally, my DEF CON talk comes around, and of course, being a good hacker, I wait till the last minute to actually, start testing my stuff, and I realized that in ESXi 5.5, they're actually both patched. So I'm pulling a Stewie running around, not knowing what the heck to do because both of them get patched. But fortunately, I spent a couple hours and found another one, which is the ntdsapi.dll. So literally all you have to do is, drop that DLL into the WBEM folder within System32, and it will get loaded at boot time by the VMware Tools service. So obviously the downside is VMware Tools has to be installed, right? So it's more useful on servers or in a virtual environment. However, we're going to go from good, better to best, and right now we're moving on to the best category, okay? The best is this one, and this is to create persistence in Windows. All you need to do is create a new key at that registry key that I've specified, and then a value within that key named driver. And the value of the driver is just the DLL that you want to get loaded. You drop the DLL into Windows System 32, and at boot, Windows will load that DLL within the spooler, the print spooler service. The upside is you can create as many as you want. You want multiple DLL persistence, you create multiple keys, each of them with a value of driver, each of them specifying a DLL, and at boot, as many persistence or DLLs that you want to run will be executed by the print spooler. So, I think it's time for some demos. That's enough of me talking. Let's move on to some fun stuff. Okay. Oh wow, that is really big. Yeah, I was waiting for that. Okay, all right. I think that's close enough, right? Sorry. Hopefully everything fits. I tried to resize the font and everything, so I cannot even see that. Is that run as administrator? Okay. I can see why most people don't extend the desktop. Okay, so we're going to, first off we'll do the first persistence, which is the ntdsapi.dll, okay? So that's in demo 2. And, man, that's really freaking small. Okay, so all we have to do for this one is there's no registry modifications required. We just have to copy that test DLL to C Windows System 32 WBEM, and then we'll name it NTDS API. Did I type that right? Can anybody see? Yeah. NTDS API.dll, okay? All right, so one file's copied. So that's it. Okay, there's no registry modifications necessary. What this DLL does is it's similar to the first DLL. It shows what process loaded it and then dumps some information out to the debug view. So we're going to reboot. Actually, I'll just type it because it's a little easier. Okay. So what I'm going to do is I'm going to log in as fast as possible because, again, it's being loaded as system, so it doesn't wait for me to log in to execute the backdoor or the DLL. It's going to execute as soon as the service gets started. So I'm going to log in quick, start up the debug view, and we should see that DLL being executed. Okay, so it should say something about what process or what PID it's running from and where the DLL is located at. Is that what you guys are seeing, for those of you that can see it? Okay, so that's the first one. Again, this requires that VMware Tools is installed. So there are some requirements there, but if it is installed, then you have a super stealthy persistence technique in Windows. Okay, so now we'll demo the second one. Okay. All right, the second one, like I said, I think the second one is pretty awesome. It's super stealthy, and the best part about them is, when you can find logic vulnerabilities within Windows, because those are a lot harder to patch. So what we have here is we have there should just be a Aramis. I codenamed it Aramis. So if we run that, it just takes the DLL, like I said, it must be in System32, so we'll go ahead and copy test DLL to C Windows System32, and we'll just call it aramis.dll. I think I typed that right. Okay, one file copied. So now if we just run aramis, and then to specify the DLL that is in System32, and then the test app that I wrote just asks if you want to load it now, and we'll go ahead and say no because we're going to reboot the box anyway. Okay, so if we shut down, this is basically the same test DLL, so when we reboot we should have two persistence mechanisms on this box now. So the first persistence should be running out of VM Tools D. The second persistence that we just installed should be running out of spoolsv.exe, both of which are system processes. Okay, so there's one, and it looks like there's the other. So they're both running as they should. One should be running from VM Tools, and the other one from spoolsv. So right there we have two, pretty stealthy persistence techniques. A lot stealthier anyways than installing a service, right? Because service creates all kinds of logs. It's kind of a dirty persistence technique in my opinion. But it does work. Okay, so now let's talk a little bit more about Windows APIs. I guess as a super quick prep course to throwback, we're going to distinguish between WinHTTP and WinINet. Those are the two main libraries within Windows that Windows provides you, when you want to write a backdoor. So WinHTTP is intended primarily for services. WinINet, think user space. Okay, so WinINet will automatically pull user settings. It'll automatically do like NTLM authentication. Has anybody ever had problems getting out of a network that does NTLM authentication using Meterpreter? Yeah. Anybody else? Okay, well, the reason why is because there's a certain flag that you have to set. It's called the Internet Flag Keep Connection. And that flag will automatically tell WinINet to do NTLM authentication at the proxy. Okay, so as something as complex as NTLM authentication, it can easily be enabled just by setting a flag within WinINet. Oh, great. All right. Well, I don't drink, but I came prepared with Mountain Dew, so.
This is about us, it's not about you.
Oh, okay, sorry.
You can just stand there, look pretty. Well, we got it.
That's it? That's all you get?
That's all you get.
All right. Oh, sorry. I'm not used to it.
Drink it, did he?
We're not there yet.
Thank you.
Excuse me.
On a special edition of Shot the Noob, we have a new, in addition to our new speaker. Congratulations. We also have a new attendee. Nikita, everybody, say hello to Nikita. But anyway, it is very tough to get accepted at DEF CON. Congratulations. How about some love for our new speaker? Cheers. You're done. I got this.
Okay.
I would have done this very differently. In fact,
You gotta hit the arrow key.
there we go. All right.
You're stealing my thunder.
Oh, shit. All right, listen, you know what? This is all crap. I'd have done it differently. You just take it. I can't even be on stage with this anymore. Who took my alcohol?
I have it.
Oh, shit. Oh, no.
Okay. All right, thanks, guys. That was fun. Okay, so we'll finish talking about the two different HTTP APIs within Windows. As I was saying, the WinINet one is super easy to use. You know, doing something as complex as NTLM authentication is as simple as adding the correct flag within the API call. It's important to understand the distinction because for throwback, we actually used WinHTTP. You know, based on, you know, when doing a penetration test, what's the first thing you want to do? Well, you get access to a user's workstation, and then from there you want to escalate privileges and, you know, run from a service, right? So in order to do that, that's why we decided to go the WinHTTP route, is because it's tailored more for services. So the backdoor itself is written in C++. The control panel and the LP portion are written in PHP with a MySQL backend. It was designed for stealth. You know, like I said, we're trying to converge the penetration test with what an actual attack looks like. So we want to build tools that support that methodology. So it has persistence built in, both as a DLL and as an EXE. Here's kind of a brief overview of how it works. An attacker, you know, sends a spear phishing email, or, you know, however, use your imagination to gain access and infect an end user's workstation with the throwback executable or the throwback DLL, and gets code execution on their box. Throwback then, you know, starts beaconing out of their proxy or firewall out to the throwback LP, which again is a PHP interface, and it has a control panel that we can then send command and control commands to the throwback backdoor. You'll notice that there's two throwback LPs in this scenario. So you can have it round robin and randomly select one of however many LPs you want to configure throwback to call back to. You know, if you want to set it up to 10, then it'll randomly select one of the 10 to call back to, however often you tell it to call back. So here are some other features of throwback. A robust proxy detection. So you remember I said that we used WinHTTP. So WinHTTP doesn't have the robust you know, user proxy settings that WinINet has. So what we ended up doing to get around this was, because it does run from a service, you can impersonate users a lot easier. So what we did was we decided to mount each user's ntuser.dat file. If it's not able to get out initially, it tries mounting their registry file, looks in their user settings for proxy settings within Internet Explorer, and then grabs those proxy settings and uses those to try to get out of the network. And it does that recursively for all users that have logged into the box for their proxy settings. Like I said, you can also set it up to use distributed LPs. So instead of calling back to the same LP every, you know, hour or 15 minutes, you can set it up to call back to 5 or 10 LPs. and it decreases the traffic to each domain. It also uses the MSGRPC interface to generate MSF payloads, which we'll be demoing in a minute as well. It uses RC4 for encrypted communications, so you can configure it to use HTTP or HTTPS. Either way, the actual payload data is encrypted using RC4. It also implements reflective DLL injection. We'll be demoing that as well. Reflective DLL injection, from a malware writing perspective, is the coolest thing ever. It just allows you to run other DLLs from memory. So we'll be demoing that as well. And then lastly is string encryption. So if someone does grab the binary and starts doing some reverse engineering on it, all of the strings within throwback, before you put, like, for example, any of the domains that you wanted to call back to, you have to run it with you have to enter them into a Python script that spits out an integer array that you then copy into the C file, so the strings are not stored in clear text within the binary. So, a lot of you might look at this and be like, okay, well, what's the difference between this and Meterpreter? Well, I don't think anybody would ever say that Meterpreter, and again, I really like Meterpreter, but it doesn't really have the best OPSEC, right? So, when you type in Meterpreter script, it just like randomly generates an executable, on target, or randomly generates a service. Whereas this is designed, more for stealth, and it's not an interactive tool either. Meterpreter is for interactive access, an interactive shell on a target that you have access to. So with that, it doesn't have as much functionality as Meterpreter either. It's just more of a bare bones backdoor that can provide, stealthy, persistent access within a network.
Yeah, throwback.
All right, well, we'll be seeing a demo of it. This is the interface. So remember that I talked about how there's a control panel written in PHP. So this is how you control all the different boxes that are calling back. You can see in this case there's 4 that are calling back. The first 3 are set to call back every minute. The last one is set to call back every 10 minutes. That's changeable. When a target calls back, you can say, hey, I want you to now call back every 4 hours. If you're not going to be doing interactive operations for a while, you can change that and modify it. So that's the interface. Again, we'll be doing a demo right now, actually, on how to do it. And hopefully I don't feel like doing this to somebody by the end of it. Okay. So what I wanted to do was just kind of run through, when doing an assessment, the general flow of an assessment, right? So here we have a Kali VM, and I'm going to pull this up here. Hopefully that's big enough so you can kind of see it. I know I can't see it on that little monitor, but we're going to be using the exploit. It's an old IE10 exploit, but we've customized it for this particular version of IE10 that we'll be using, and we creatively call it 2 girls, 1 exploit. The rest of the commands are pretty basic. Setting it on port 80, it's just an IE10 exploit. The payload, though, is a custom DLL inject payload. And I think this payload is one of the most underrated payloads in Metasploit. It allows you to use a custom DLL as a payload within Metasploit. So instead of relying on, Meterpreter or, potentially getting flagged by AV, you can use a custom DLL inject payload and inject whatever, custom DLL that you want. So I suppose I probably should have started that up. That's just within that resource file. So I'm going to start up the resource file there. Let's see. Okay, and while that's going to start up the exploit. Okay, have a lot of things going on here. So this is the interface to throw back. It is available on GitHub now. So we'll log in. So you can see there's one box calling back. It's just a test box. You can see the last callback was like yesterday, I think, when I was testing some stuff. So what we're going to do, like I said, is come into here. The exploit, yep, it started by now. So now, obviously it doesn't matter how you deliver the payload. That's not what this is about. This is about, using throwback as a custom payload within Metasploit. So and I think that's it. Just /index.php. So that should, so what that's going to do is, exploit the browser, obviously. It's going to inject the custom DLL into memory. And so now if we pull this up, we should very shortly see a new box pop up because our DLL just got injected. So from here, we have another target. We can install persistence on it. At this point, we're just a DLL running in memory because of the way that we delivered throwback. If you were to deliver it through like a macro attack, as an executable, then it would automatically install itself, as persistence. So, you can do all sorts of stuff. You can create a process list, which I think is this second one. No, that's not it. Oh, that's actually change callback time, I believe, right? Change callback time. Okay. So that one is create task list, I think. I don't know what it is, but whatever it is, we'll run it. So you can see we just queued it up. There's now a task waiting for throwback to execute. When it turns pink like that, that means it actually is currently executing it. So we can come in here and you can see it's picked up the task, and then it should return the output from that task. Yep, it was a task list. So when we have access to a box, what do we want? Do we want do we want this, or, we want shells, right? Isn't that what everyone wants? We always want a shell. So one thing that we decided to add was, you can see it's calling back every minute. So what we're going to do is there's a functionality called metCreator. And what this does is this will generate a Metasploit payload, a interpreter payload. And we're going to create a raw one. And let's do, I don't know what that is. I think that's the reverse HTTP x86. HTTPS, okay, that works, sure. Okay, and then we're going to go back to our Kali box. Let's see what IP this is. And we'll go ahead and kill this because we don't need that anymore. And what's the IP? It's like 20.110? Okay, all right. Okay, so we'll come back, oh, not that, this. So we want the callback to be to 192.168.20.1. I think I did that wrong. Okay, is that right? And port 443. Okay, so now we're going to create the payload, and what it's going to do is it's going to use the MSG RPC interface within Metasploit to create the shell code to execute this payload in an HTML file. It's going to base64 the shell code, so it looks semi-normal. And then what we'll do is we'll queue up throwback to call back to this HTML file, grab the shell code, and it's going to inject it into memory. So Meterpreter will never even touch disk. We'll be running from memory. So once we click create payload here, it creates this handy little output for us. We can just copy that to create our handler. So now we'll come back into here. Click paste. So one thing that's important to notice is you'll notice I changed the exit function to thread instead of process. That's important because when we inject the shell code into another process, and when we quit out of our interpreter shell, we don't want it to kill the process, we just want it to kill the thread that we created within that process. So we have our handler listening there. And the payload's been generated to that HTML file. Okay, so now let's go ahead and queue up the task. Okay, I think it's that one. They should say download and execute shellcode. And then the argument in this case is the process ID or the PID that we want to inject into. In this case, we're just going to cheat And I'm going to just look in the process list and type one in. We already ran a task list, so we could just look at the task list, but it's hard for me to see, so. Okay, so Notepad++ is running, so we'll inject it into Notepad++. So it's 1460. 1460. Okay, oh, and then you have to select the target and then submit it. Okay. And we should only have to wait at most a minute for it to execute it. Okay, so it looks like it executed it. So if we go back now to our Kali box, we have an interpreter shell running in memory. Okay. So that went well. Okay, so going forward, like I said, Throwback has been published on GitHub. You'll see the link in the next slide. We've used it for literally the last 4 or 5 years. So at this point, I feel like it's pretty stable and mature. But we obviously want to make it a community-based project. So we're open to feedback. We're open to other people's ideas on improving it. We'd also like to create modules. Again, because it implements reflective DLL injection, it would be super easy to add like a keylogger module, a Mimikatz module, hashdump module, things like that. So in the end, the final shameless plug is if you're interested in this type of writing custom malware, custom backdoors, then we're actually having or holding a course that focuses especially on this, on Throwback and creating your own malware in Black Hat Europe and Black Hat East Coast later this year. I'm also involved with blacksquirrel.io if you're interested in any spear phishing and things like that, custom spear phishing attacks. That's another super awesome project. You should check it out if nothing else. Accounts are free. So thank you for attending the talk today. I appreciate your time and have fun at DEF CON.